Well, thank you very much, Kevin, for the introduction, and thank you, colleagues, for organizing this event and for joining us today. Very pleased here today with my colleague Sky Chen. Sky leads much of the technology work in our group, and Sky will be doing the presentation together with me today. I'd also like to acknowledge our co-author, Marina von Keyserlingk. So today, to get us started, we've got sort of a bit of a two-part presentation. We're going to start by describing the results of a review that Nina and I did recently on the way papers describing technology in dairy are framed. In other words, what are the stories we tell around the technology? How do we situate that? And I think that's an important way of beginning our discussion today. But because we are also a group of technophiles and we've been working on ways of trying to integrate technology in issues around animal welfare for many years in our group, we couldn't give up the opportunity to also share some of the cool new technologies that we're pursuing. And Sky's going to talk about one particular example that I hope you'll find interesting. Before I get into the details, I'd just like to very much acknowledge our funders for the animal welfare program. We are funded by the dairy industry, and the work we do is very much intended to try to help dairy farmers and the cows that they care for. And we think that technology has a positive role in doing that. Okay, how can we do a presentation on technology without including a few AI-generated images? So this is courtesy of Sky. So thank you, Sky, for getting us started with that. Yeah, I guess it's important to say that all stories, including all academic writing, the storyteller contextualizes that in some ways. It's not surprising, perhaps, that often we see contexts around welfare being used when we describe technology because it's one of our main issues of the day. Indeed, more and more, we're also seeing issues around sustainability being used as a context for this kinds of technology. And I guess the part of my first part of the presentation before we leave over to Sky is really to get us as an audience to think more carefully about the way we frame. We can't prevent framing, we'll do it, but to be aware of it and to be maybe a little bit more skeptical of some of the frames we use and to be a little bit more careful as researchers about the kinds of claims we use. And I think welfare provides some good examples for how we can do that. So here's just a bit of sort of technology of a systematic review. This is a classic sort of prisma diagram showing the way that we search and the way that we end up with our final articles. We started off by doing a systematic research on dairy cattle welfare papers published in English over the past 10 years that linked somehow welfare with technology. When we read those papers, we found that 28 really were relevant to the topic. And of those, about half and half were reviews versus empirical articles. So a lot of those are reviews, important to note. In relation to our take home today, really, we can see that the majority of those articles that used a welfare frame used an exclusively positive welfare frame. So they only talked about welfare benefits. Of the 21 papers that used an exclusive frame, 20 of those used an exclusively positive and only one used an exclusively negative. We see some papers that are using both. Interestingly, the majority of those papers come from the social sciences. Those are papers actually interviewing dairy farmers. And of course, you interview a dairy farmer about the technology, they'll talk about ways the technology can be useful as well as the challenges they're having with the technology in terms of animal welfare. So as you'll see in a minute, I'll talk a little bit about the kinds of framings that are used and then talk about some ways which we can maybe improve things. Okay, so on to the welfare benefits. First, of course, these were heavily covered in the literature that we reviewed. And I'll start off with an example which I think is relatively positive. And those are cases where people were very careful to articulate exactly what the technology was doing and then carefully describe the logic linking the inferences between the actual measures with the specific claims. So for example, a number of accelerometer papers are interested in measuring aspects of line time or some other aspects of cattle activity. In some cases, there can be logic linking those types of measures to lameness. People who are aware of that literature will know that that path is not always an easy one. It's a bumpy path, and it needs to be done very carefully. But there are some bases for drawing careful inferences there. Then also, we see sometimes people linking ultimately the technology with welfare, just to walk people through the especially bumpy path there. Now, in one way, of course, it's obvious. If a cow's lame, that's not good for her welfare. So all else is equal, a lame cow is going to have worse welfare, shall we say, than a healthy cow. But all else is rarely equal. And even if we have technology that does a good job of assessing lameness, that technology might come with other types of welfare risks or benefits. And we need to be very careful about making overall claims around animal welfare. So for example, as I'll talk about in a minute, one of the welfare risks associated with sensor technology, wearable sensor technology, are the lesions associated with that. And so even if the technology is doing a good job of assessing which cows are lame, it might also be doing a bad job in a way in terms of creating lesions. So we need to be, I guess, take-home message from this is the best cases of the literature we saw are those which made very specific claims about exactly what was measured and carefully laid out the logic linking those claims with very specific welfare outcomes. Unfortunately, not all the literature did this. And so here's some examples of claims which were much woollier, I think difficult or perhaps even impossible to demonstrate in any way. So here's one by Silva et al. Saying that they were talking about the technology as able to improve production, breeding, health and welfare, and environmental sustainability. So these kind of claims may be true in some specific respects, but we would need to see very specific logic and data linking the actual outcomes we're measuring with the kinds of conclusions that we're making. Okay, onto the welfare risks. As I said, very little literature dealt with this. This is a few bullet points from one review article which dealt with the risks, and here are some of them. I already alluded to the first one of lesions. A very common one when you talk that when the research on talking to farmers shows is that farmers are also concerned about changes in the type of interactions they have. There's also concerns coming from both farmers and also general society, how somehow or other this technology will result in farming becoming more industrialized, and that also that the animals are more likely to be treated simply as a tool, as another piece of technology themselves, so diminishing the moral status of the animals. Take home really from me on this is that is just for us to be more aware as a field that and as authors, I guess especially, is that whenever we tell stories about technology, we're going to use some type of framing and to be conscious of that, and then also to be very careful to provide the logic about exactly what the technologies we're describing are actually doing, and the logic linking that with welfare outcomes. And I also think it's important that we strive to ensure that we're also carefully examining and doing research to describe both the risks and the benefits. Not assessing the risks, I think, does a disservice to our field. Because these are real concerns for our farmers, these are real concerns for society, and if we want ultimately our technologies to work, we can't be perceived as simply people who are out there peddling, selling these technological wares. Rather, we need to be seen as scholars that are seriously trying to understand the risks involved and working to mitigate those. But now on a more positive note, I'd like to pass this over to Skye and have her tell you a little bit about one of the new technologies that we're working on now.
Yes,
Skye.
absolutely. Thank you, Dan. Hello, everyone. It's my great pleasure to be here. So just like Dan said, apart from being very cautious about how we frame the technologies, I think it's really important for us to think about how are we labeling our ground truth data for training? Like what kind of data are we inputting to our machines to learn? So at UBC, we are trying to refine this lameness assessment method to better label lameness data so that we can enable large quantity of lameness videos being labeled in a really fast and accurate manner. So currently, we are always using traditional lameness like gait scoring method. However, our previous work has shown that asking people to assess which cow is more lame is a much easier and intuitive task than doing the traditional absolute gait scoring. And that is the same case even for people without any background in agriculture. When you ask them which cow is more lame when they're seeing two cows walking side by side, it's really easy for them to tell which one is more lame. So based on this work, we converted all those peer-wise lameness assessment results into a continuous lameness hierarchy. So for example, if we have cow A that is more lame than B, and cow B is more lame than C, then of course you would expect cow A to be more lame than C. So in this study, we recorded 30 videos of different cows walking, and we assessed lameness in 2 different methods. So the first, we did the traditional gait scoring on a 5-level scale, recruiting 5 experienced lameness assessors, each scoring 3 rounds of the same video in 3 different days. The second one method we used is peer-wise lameness comparisons. So we compared everyone with everyone in the video set of 30 cows, generating 435 video pairs in total, and we recruited 4 experts to do all the peer-wise lameness assessment. After that, we used ELO rating algorithm to convert them into a lameness hierarchy. So what we found is that when we ask different experts to score the same cow, they don't always agree with each other. So here the ICC measures the level of agreement among different experts. In the ideal world, we want ICC to be at 1, but if perfection is at 1 and then we are only reaching 0.42, that is not good at all. So in fact, even if you ask the same expert to score the same cow, the same video of the cow at different time point, they would not even agree with themselves. So those frustrations lead us to this creation of the lameness hierarchy methodology, because we think that just like many other diseases or phenomena in the biological world, lameness should also be a continuous skill. So here we put cows on the x-axis from the most healthy to the most lame, using our lameness hierarchy method. And each of the hill distribution here in plots represents a unique cow. The further they are to the right, the more lame they are considered in this lameness hierarchy. And we color-coded this plot using the average gait score after 15 rounds of traditional gait scoring. So the color gradient from yellow to purple represents average gait score at 1 to 5. So for example, for the purple, for that purple hill on the very right, that cow has an average gait score of 3.9, which is also rated as one of the most lame cows based on the lameness hierarchy methodology. So, sorry, coming back. So we also wanted to link our new methodology with the old method of gait scoring. And this is why we create this as plot. And then if perfection is at 1, then a Spearman's correlation coefficient at 0.77 shows that our new methodology is still in high agreement with the traditional absolute gait scoring after extensive rounds of scoring them. We further generated lameness hierarchies independently for 4 different experts, and we found that for experts, when they generate their own lameness hierarchy using this methodology, they agree each other on a pretty high level, and with the ICC shown at 0.81. Remember that when it's traditional gait scoring, our ICC, the reliability was at 0.42, which is really low. So as shown before, this lameness hierarchy method is really promising when it's conducted by experts. However, experts are expensive to hire, and then they're extremely busy as well. So it took me about 3 months in the past to get the previous plot that I showed you, because it's so hard to coordinate everybody's time to do all the peer-wise lameness comparisons. So our life would have been much easier if human assessors are available upon request within seconds, and they're available 24/7. And such humans actually exist. They're called crop workers from the Amazon and Turk. And that's what we did. So we recruited on average about 18 crop workers per video pair, asking them to do the exact same thing that experts did, to do peer-wise lameness assessment, assessing which cow is more lame. And after that, we generated a lameness hierarchy just based on the response from crowd workers, and we plotted them on the y-axis. And on the x-axis, we have the lameness hierarchy generated by the experts. And here we're showing that ICC at S 0.85, meaning that the experts and the crowd workers are in high agreement with each other in terms of which are the most lame cows, which are the most healthy cows in this lameness hierarchy methodology. So in conclusion, we created this new methodology to enable the labeling of training data of the lame cows in a really fast and accurate manner. So the take-home message for today is first that we wanted to suggest, like, for researchers to reconsider how we frame different technologies to have a more balanced framing of when we discuss new technologies and be more specific when we talk about welfare claims. And we also are showing you guys the really amazing comparative approach that UBC just developed to allow for this rapid, efficient, and accurate labeling of the data. Yeah, thank you so much for everybody's time. We're open for any questions.